Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 9. This is Section 9.1 and the Pythagorean Theorem, which you've heard about and known for a number of years. So the Pythagorean Theorem, as you recall, it just says that if you have a right triangle, the squares of the lengths of the hypotenuse is equal to the sum of the squares of the two legs. So we have a squared plus b squared equals c squared. And that's only when you have a right triangle. So that's the Pythagorean theorem, and it always works. Pythagorean triples is when you have three integer numbers, such that a squared plus b squared equals c squared. So the most simple ones that we have is 3, 4, and 5. So if you take that 3 squared plus 4 squared, you're going to find that is equal to 5 squared. It's also interesting to note that if you take a multiple of 3, 4, and 5, say multiply by 2, you get 6, 8, 10, then these are also a Pythagorean triple. So if you take 6 squared plus 8 squared, you'll get it will be equal to 10 squared. And the same thing if we take 3, 4, and 5 and multiply by 3, so 9, 12, and 15. They are also a Pythagorean triple. So any multiple of a Pythagorean triple is going to be a triple itself. There are other famous triples. There's 5, 12, 13, 8, 15, 17, and 7, 24, 25, just to name a few. There are many, many more of these. You can also take one of these and divide by, say, 2, and we come up with 2.56 and 6.5. Even though they're not integer numbers, they still fit the equation of a squared plus b squared equals c squared. This is not considered a triple because it's not integer. Pythagorean triples have been around for a long time, and we've actually dug up Babylonian tablets that are 3,700 years old that show these. So they've been known for a very long time. Let's compute x in this triangle, and let's determine whether it's a Pythagorean triple. So to compute this, we're going to say that the two legs, the sum of the two legs squared, is equal to the hypotenuse squared. And if I work this out, then I'm going to get 14 squared. I'm going to subtract 7 squared from both sides. And if I have 14 squared and subtract 7 squared, then I get 147. So x squared is equal to 147. And you can see the 147, you can't really take the square root of that and get a nice integer number. So no, this is not a Pythagorean triple. It can be computed, and it'll be somewhere around 12.1, but it's still not a Pythagorean triple. Now let's take a look at the skyscraper. The skyscraper problem has two right triangles, and each right triangle has a leg of 47, 57, and a leg of 23, 26. So we can compute the third side here by just using the Pythagorean theorem. And I'll leave that to you to come up with the solution for that. The converse of the Pythagorean theorem says that if we have three numbers, we have a triangle, and the three sides are such that we can make one side c squared equal to the two legs, the sum of the two legs squared, then we have a right triangle. So if it fits this formula, then it's a right triangle. Are these right triangles? Well, let's take a look at this. We have 8 and 7 and the square root of 113. So let's just write this out. We have 8 squared plus 7 squared is equal to the square root of 113. And we take all of that and make that squared. Well, this is easily 113. But let's see if, and we have a question mark on this, 8 squared is 64, and 7 squared is 49. And it turns out that these two do equal 113. So this equation works out, therefore this is a right triangle. Now let's take a look at B down here. We have 36 and 15, and the longest side is this 4 square root of 95. If we take 36 and we square it, and then we add 15 and square that, does that equal 4 root 95, the whole thing squared? And if you work it out, you will find that they don't equal. Therefore, it is not a right triangle. Pythagorean theorem lends itself to an inequalities theorem, and that says that if C is the length of the longest side, the following statements are true. If C squared is less than A squared plus B squared, then we have an acute triangle. So here's an acute triangle where all the angles are acute. But if C squared is greater than A squared plus B squared, then we get an obtuse triangle. So this side C is longer than, say, a right triangle. Then this angle is going to get bigger than 90 degrees, therefore we have an obtuse triangle. So we can use the Pythagorean theorem and inequalities to determine what type of triangle it is. As you recall, back in chapter 6, we could tell whether or not we have a triangle when we look at 3 lengths. So if I look at these 3 lengths here, the way that we can tell is that the length of 2 sides, the sum of those two, have to be greater than the third side. And if I pick the longest side, which is 7, and add up these 2 lengths, you can see quite easily that this will make a triangle. On the other hand, over here, the lengths of the 2 shorter sides, when I add them up, they don't come close to the third side. Therefore, I cannot make a triangle out of this. Now, if I have the ability to make a triangle out of the first one, so there's my proof. If I can make a triangle out of the first one, then what kind of triangle is it going to be? Well, the way that we can tell is we form our inequality. We take the longest side, 7, and square that, and then question mark, check what happens when we take the other 2 sides and square them, plus 3 squared. Well, we get 49 for this side, and we get 25 plus 9 on this side, which makes for 33, or 34, I'm sorry. But 34 is less than 49. Therefore, that means that this has to be an obtuse triangle. So now we know what kind of triangle it is. Here we have some segments. Let's first verify that we can make a triangle out of it. If you look, we have 6.1 is the longest side, and you can see easily that when you add these together, they're greater than 6.1, so we can form a triangle. But is it going to be acute, right, or obtuse? So we take 6.1 and we square that, and then on the other side we take 4.3, square that, and add it to 5.2 and square that. And if I take 6.1 and square it, I get 37.21. And if I take 4.3, square it, and add it to 5.2, squared that, I get 4553. And we can see that the third side is going to be less than, so this is going to be an acute triangle. The second one, I'm going to leave it to you. Let's just determine that we can make a triangle out of it. If you see we have 3.5, that's going to be less than the sum of the other two sides, so we can make a triangle. Now determine whether it's acute, right, or obtuse. And we'll talk about this in the next class.